Hi everyone, welcome to this second video on lesson 16 of the Sound and Light scheme on colours. This is where I am going to attempt to model some harder examples in the way that I would model them to students. There is a very strong chance I will tie myself up in knots here or make some elementary physics mistakes. So if any of you are watching and can spot any physics mistakes that I've made, please do get in touch and I will remake the video based on an improved understanding. But for now, I think I've got my head around this. So the examples that I modeled in the previous video were all super simple. They were perfectly red tomato, perfectly green cucumber, things like that, or black and white. And in that case, colours, and the reason we see colours, it's fairly clear cut. It's not too complicated. Because actually only one colour of light ends up being reflected. So that's kind of fine for students. Where it gets messy is in colours that are a combination of one or more other colours. Sorry, two or more other colours. And the reason it gets messy is because the primary colours of light, red, green, blue, are different to the primary colours that students are taught about in art. And that's because it's all to do with the difference between emission and absorption. Now, if you think about a computer screen, you might have heard of computer screens using the RGB color scheme. The idea there is that a computer screen emits light, and if a computer screen can emit varying amounts of red, green, and blue, and you vary the amount of red, green, and blue that it does emit, you can essentially make any color in the spectrum. Hence, red, green, and blue are the primary colors of light. Now, what you're doing when you're painting, as I'll try and explain, although possibly not very well, what you're trying to do there is something slightly different because you're not emitting light. It's about what colours of light you're absorbing and what colours of light are being reflected. So it's a slightly different case, and I think that's why the primary colours in art are different. So I'll have a go at explaining this. This is really difficult, and I think unless you've got a group who's really confident and really wants to push themselves to find out more, I would be tempted to skip this part of the lesson. But for those of you who are intrepid and with intrepid students, let's have a think about a banana. So this is a slightly more complicated example. So I'm going to sketch a banana here like this, and we're going to imagine this is a perfectly yellow banana. Now again, this is where it's kind of complicated because the idea of perfectly yellow is a little bit problematic in itself, but let's just carry on regardless. So what we can do is draw the same sort of diagram that we were drawing before. The same sort of diagram. So I'm going to draw my three colours of light, my three primary colours of light coming in. So red, green, and blue. Now, here I would refer you to the, I've included a diagram in the slides with the primary colours of light, but yellow light is actually made up of red light and green light. Now already, that's alarm bells because yellow is one of our primary colours in art. We'll come back to that in a minute. But the point here is what's going to happen if yellow, a perfectly yellow object, is actually reflecting red and green light. Well, all that means is the reason a banana appears yellow is because it absorbs all of the blue light and it reflects all of the red and the green light. So what arrives at our eye is red, green light, like this. And red and green light combined, we perceive the rods and cones and whatever it is in our retina. I would have to do some revision on that part of the course, but all of our receptors in our eyes detect that combination of red light and green light as yellow light. So that's why a banana appears to be yellow, because yellow absorbs all blue light. So that one isn't too difficult. There's another one we could do about magenta. Magenta is slightly different. Magenta absorbs all green light, but essentially it's the same point. And you can model that and have a go at other ones to do with cyan and things like that as well if you wish. The last thing I'm going to do, and again, I probably wouldn't go through this with students unless, I mean, I'd be very, very careful, but I thought it might be helpful for you guys. And again, I'm just using my own understanding of this. I may be wrong, so if I am wrong, please do correct me. But a student might ask, well, hang on, why is it then that yellow is a primary colour in art, but it's not a primary colour in science? And maybe a good example would be, well, why is it that green light is a primary colour in science, but we know from art that if you mix blue and yellow together, you get green? Well, my understanding is what's going on here is as follows. Let's imagine you've got some yellow paint, a blob of yellow paint like this. What's happening here? Well, this is exactly the same as what we've just sketched with the banana. So if your red light, I've dispensed with a ruler now. Obviously, if I was teaching this to students, I would use a ruler. Your three colours of light are entering. Yellow objects absorb all blue, because yellow is a combination of red and green light. So the colours of light that exit the yellow paint are red and green. Maybe I'll add some arrows. And the combination of which makes yellow light. So that's why yellow paint works. It absorbs all the blue light. Now my feeling is here, I'm just going to find a cyan. Maybe that's a better cyan here. My feeling is here that when we talk about yellow and blue, maybe what we're really talking about is yellow and cyan. So cyan is a mix of green and blue light. So what's happening when you have your blue paint is that you've got three colours of light coming in. Because cyan is a mix of green and blue light, the red light is being absorbed, green and blue light are being reflected, and therefore what is reaching the person's eye is green and blue, and that's why it appears cyan. Now my feeling is that when you mix these two colours, and when we talk in art about mixing yellow and blue, actually we're just being a bit sloppy with language. My guess is we're actually mixing yellow and cyan, so that when we mix these two colours together, and I'm going to draw a kind of blob of paint without shading it in yet, well, what's happening here is, where are we? If I draw my three incoming colours of light, as always. Now, I know that because there's yellow paint there, that's going to absorb all the blue. And I know that because there's cyan paint there, that's going to absorb all the red. So what is the colour that's escaping? Well, it's green, and therefore, what colour does it appear when I mix the yellow and the cyan together? Well, it appears to be green. That would be my guess as to why in art these two things happen. And again, I'm putting this video on YouTube, having not done loads and loads of research on this. So if anyone does watch this and wishes to research more, or knows the answer already and is willing to tell me I'm wrong, that would be really, really helpful. But that is my way of understanding it. Now, as I say, I would be very, very careful about going through this with students. This is much more for teachers than it is for students. I think this is what's going on. I would recommend that you do your own research, and like I say, please do prove me wrong, or correct me if I have got that wrong. But the main part of this lesson, just going back to what was covered in the previous video, the main part of this lesson is just this idea that when light reaches objects, it's either absorbed or reflected. And if students are clear on that, and the different colours of light are absorbed and reflected by different coloured objects, we're pretty happy for the sake of a Year 7 lesson. So apologies that is not the clearest video, but I hope that gives some sense of some of what's going on here. And again, yeah, please do research more, and let's keep the conversation going. It would be helpful to hear what people find out.